In this video, an ENACT coach will model 2 strategies teachers can use to support students in taking ownership of computational thinking practices. We call these strategies prompting and pointing out. The coach will model how you might prompt students to use computational thinking by making suggestions about how students can use CT practices to approach a problem. Then the coach will model how you could point out when you observe students using a CT practice, whether they realize they were doing so or not. The examples in this video focus on making estimates for decimal calculations, but the ideas could apply to any problem where students use estimates to judge the reasonableness of their exact answers. Let's watch an example of the coach prompting students to use debugging as they estimate the cost of groceries.
This problem is going to ask you to estimate the cost of Ting's grocery bill. So here's the items Ting is buying and the total cost of each item. Chips, salsa, cheese, ground beef, and jalapenos. What do you think Ting is making? After you've found your estimate, the problem is also going to ask you to find the exact answer and then think about whether your estimate was close enough to be useful. What do you think that means? Why might an estimate be useful? What can you use an estimate to do? Yeah, that's one idea, is that estimates can help you make sure you brought enough money. So you don't have to know exactly what you're going to spend when you go to the store, but you do have to know you have enough, and an estimate can help you decide that. It's another idea. Yeah, maybe it can help you check whether the cashier made a mistake when they found your total. So if you make an estimate and the cashier says you owe much more or much less than what you expected, maybe you can say, let's check that just to make sure. Great. So when you're thinking about this, about whether your estimate is close enough to be useful, you're going to be debugging. But remember, that's just the first step. If you do decide your estimate is not close enough to be useful, I want you to talk to a partner about how you could improve your estimation strategy or maybe find and fix some mistakes in your work.
Prompting students to debug an applied math problem can help them connect debugging to math situations they encounter outside of school. Now let's watch again as the ENACT coach prompts students to use pattern recognition on a problem about estimating the cost of flooring.
Let's look at what this problem is asking you to do. Letitia wants to replace the carpeting in her bedroom with hardwood flooring. Hardwood flooring costs $23.95 per square meter. And then it shows this diagram of her room. It also gives you some estimates that Letitia made for the cost of the floor and asks you to try to make sense of what she was doing. When I look at these estimates, the first thing I notice is there's some things that are the same across them. There's some similarities. So I wonder if we can do some pattern recognition to help us solve this problem. When we do pattern recognition, what are we looking for? Yeah, things that are the same or different across different examples. Right? So let's look at the estimates. Do you notice anything that's the same across all 3 estimates? Yeah, I noticed that too. She does some multiplication as her first step, right? All 3 times. Does she use the same numbers every time? No, there's some differences in estimate C, right? So think about that. Remember, when we do pattern recognition, we're not just finding the patterns, we're also trying to make sense of why they're happening. So think about why Letitia might be doing multiplication as their first step in her estimate, and also why she might be using different numbers. And maybe that'll help you make sense of Letitia's thinking.
The coach helped students to see that pattern recognition requires both looking for similarities and differences to identify where a pattern is present. Now let's return to the grocery estimation problem and watch as the ENACT coach points out how students use debugging to improve their overall work on decimal estimation.
I heard you say that you decided your estimate was not close enough to your exact answer to be useful. So what did you do? You did some debugging. Good idea. So can we talk about your debugging strategy? All right, so what did you do? You looked over your work. I think that's a good place to start. I actually really like how you wrote out your thinking for both the estimate and the exact answer. Having all that thinking visible makes it a lot easier to debug. So where did you start? You looked at your estimate first, okay, and what did you check? Okay, so you knew you rounded to the nearest dollar, so you looked at all the costs again just to make sure you had done your rounding correctly and also that you had added correctly. All right, and that was all okay? Okay, it's great that you checked all of your work, but just something to think about in the future is you could also think about whether rounding to the nearest dollar was the best strategy. You could try using something else to see if it gave you a better estimate. Just something to think about in the future. But what did you do next? Okay, so next you focused on these whole dollars, dimes, and pennies. And how did you check that? Oh, okay, so you had your partner read to you how many dollars was in each cost and then how many dimes, how many pennies to make sure you wrote them all down correctly? That was good. Teamwork strategy. I like that. And then you checked your addition and all of that was okay too? Great. Okay. So, but we still haven't found the bug, right? So what did you do next? Okay, so you focused on the total. And you noticed that you had written $3.40 for the pennies, when 34 pennies is actually what? Equal to how much? 34 cents. Yeah, good catch. So how did you notice that? How come you noticed that 340 was the wrong number? Okay, good point. So you noticed that the pennies were actually adding up to be worth more than the dimes, and that didn't make sense because dimes are worth more than pennies, right? Good catch. So how'd you fix it? Yeah, pretty simple, right? You just had to change to 34 cents and then get you a new total of $9.64. So now was your estimate close enough to your total to be useful? Yeah, I think so. $9 and $9.64 are pretty close. So that's useful. But just another thing to think about is that we said when we were estimating costs, sometimes it's really useful to make sure you have enough money. So you might want to think of a way you can use rounding to get an overestimate just to make sure that you have enough money.
Normalizing mistakes in math and using debugging as a strategy to check and revise solutions can help students see themselves as mathematicians. Now let's watch as the ENACT coach points out how students use pattern recognition to relate the strategies they used for the flooring problem to situations in their lives outside of school.
I heard a really interesting way Sawyer's group is using pattern recognition, and I wanted to share it with you. So Sawyer's group was working on this problem about Letitia's flooring. And they were trying to decide which of these estimates might be the best estimate for Letitia to use. So to decide what might be best, they were thinking about times in their own lives when they had to estimate a cost, like when they were saving up for something. And they thought about how when they were making an estimate of how much money they would need, it was useful most of the time for them to overestimate a little bit, to come up with an estimate that's a little bit more than they need just to make sure they've saved enough money. So since Letitia was also estimating a cost, they figured one of these being an overestimate might be the best choice because then she can be sure. So they were looking for places where Letitia rounded some of her numbers up because then that would give her an overestimate. And they noticed that in estimate B, she actually rounded up from 12 to 13 square meters for the area. So that's probably giving her an overestimate. And then she also rounded in estimate C, rounded the width of the room from 3.25 meters to 4 meters. So that's also giving her an overestimate. So they thought that just like in their lives when an overestimate was better, this might also be better to use estimate B or C. I thought that was a really cool way to think about using pattern recognition to relate different problems. Did anyone else use pattern recognition in a different way?
As you plan to prompt and point out how students are using CT practices, consider these questions. What are some strategies my students could use to solve the problems in this lesson? How might a CT practice already be a part of or add to those strategies? How might I recognize when I see my students using a CT practice? And how might I identify when it would be helpful to prompt a student to use CT?